M1 and M2 moving with initial velocity v1 and v2. And after collision, in this example, M1 is moving towards left and M2 is moving towards right. So if we consider M1 and M2 as a one system, this is one system, then forces between M1 and M2 is internal. Okay, so that will not come into the equation. So you can write in this situation P1 momentum of mass M1, P2 momentum of mass M2. This is before collision. This is the total momentum before collision. That equals P1 prime plus P2 prime. This is total momentum after collision. So that equals M1 V1 plus M2 V2. These are the vectors. That equals M1 V1 prime vector plus M2 V2 prime vector. Okay. So if I choose the coordinate system as x-axis, left is negative and right is positive, this is my coordinate system. This is my coordinate system. In this, I can write M1 P1 plus M2 P2 equals M1. P1 prime is towards left, so I can write minus P1 prime plus M2 P2 prime. Okay, so this gives the equation for total linear momentum before collision equals total linear momentum after collision. Okay, so let's talk about total energy, kinetic energy before and after. So I can write, so half m1 v1 squared plus half m2 v2 squared. This is the total kinetic energy before collision. That equals half m1 v1 squared v1 prime squared plus half m2 v2 prime squared. This is the total kinetic energy after collision. Okay, total kinetic energy after collision. In elastic collision, total linear momentum of the system is still conserved, but total kinetic energy of the system is not conserved. Okay, so total kinetic energy of system conserved means, as before, m1 v1 plus m2 v2, that equals m1 v1 prime plus m2 v2 prime. Okay, so in our case, let's consider the example. There are two masses, m1 equals m and m2 also equals m, equal masses. M1 is heading towards right and M2 is heading towards left. After collision, so this is after collision, the system is at rest. They collide and it becomes rest. So our system is M1 and M2 consist our system. So the forces between M1 and M2 is internal, so no external force. No external force. So we are ignoring friction here. We are ignoring friction. Okay, in this case. So in our case, we can write like this. In our case, in our case, in this example, both objects are at rest after when they collide. Okay, so let's put those number over here. Let's further simplify. M1 is M times P plus M times negative B, because I choose coordinate system as left negative, right positive along the x-axis. Okay, so that equals M times 0 plus M times 0, because after collision they rest. So that gives us total momentum before collision, total momentum after collision, both equals to 0 in this example. So let's find the total energy after collision. So total kinetic energy after collision. Okay, so let's say Ke initial, that equals half m1 v1 squared plus half m2 v2 squared. In our case, half m1 will be replaced by v1 is replaced by v squared plus half m minus v squared. So that equals half mv squared plus half mv squared. So that equals mv squared. So this is the total kinetic energy before collision. So similarly, we can find total kinetic energy after collision. Say Ke final, that equals half m1 v1 prime squared plus half m2 v2 prime squared. If we plug the numbers, half m0 squared plus half m0 squared, that equals 0. So we can clearly say that total initial kinetic energy is not same as kinetic energy final. They are different. In our case, total kinetic energy after collision is 0, but it may not be 0. It depends on the questions. So, but the total kinetic energy before and after, they are not equal. So in elastic collision, they are not equal. Okay. Let's consider one of the example. So let's draw a sketch here. First step of the problem. Say this is my surface, horizontal surface. This is my x-axis. First, scatter. Scatter has mass m1. It is traveling along x-axis with initial velocity v initial 1. The second scatter, m2, mass m2, v initial 2, is at rest, so certainly 0, initially stationary. Okay, so this is before collision. At some point, they will going to collide. M1 and M2 collide. So this is the collide condition. After that, according to question, they move together. They move together. So P final for first mass M1 and P final for second mass M2. is same, let's say it as V. So this is the case after collision. After collision. Okay. So if we consider M1 and M2 as one system, right? In this case, as before, no external force, no external force. So you can write total momentum before and total momentum after, they're equal. Let's plug the numbers, okay? So you can plug the numbers in that equation. So this will be 62 times 4.1 plus 77 times 0. That equals 62 times P plus 77 times P. Okay. That gives me 254.2 plus 0. That equals 139 times P. Then I divide both sides by 139. This is just algebra. Okay. So that gives me V equals 1.83 meter per second. So this is the answer for part A of the questions. Okay. Let's find the total energy, total kinetic energy before and after. So total kinetic energy before collision. Okay, I call it, say for example, symbol is KE initial. Okay, that equals half M1 P1 squared, P initial 1 squared, plus half M2 P initial 2 squared. Then plug the numbers over here. Half 62 times 4.1 squared plus half 77 times 0 squared. That gives me 521.11 plus 0. So total kinetic energy before collision is 521.11 joule. Similarly, we can find total so here total kinetic energy after collision is 232.75. So we can find loss in kinetic energy. That equals kinetic energy initial minus kinetic energy final. That equals 521.11 minus 232.75. That gives me 288.36 joule. So this is the answer of part B of our problem. Okay. So this problem is an example of inelastic collision. Based on these examples, you can practice problem 2. Similarly, you can practice this practice problem 3. Okay.